Ah, shit, yes, I am live, but shit, my screen is stuck. This is like a very common thing now. I don't know why this happens. Now it is back. Um, yep, full screen. Yep, there we go. Yes, so yesterday we were programming in sockets and we created something. We created a server, uh, server.c. This server takes in a request and prints the message that was sent by the client. And we also created a client program, uh, projects, YouTube stuff, client.c. This program sends request to that socket which is opened by the server and sends a message. And the message is this: hello server. Hello server. Let's change it a bit from client. Now clang, not clang server, client, and I'll just do clang server dot slash server. Server is running and dot slash client. Yep, message sent. Hello server from client. And if I do it again, I'll see another time. Hello server from client. Now, why did we do this? Why did we create our own server? And let me remind you that this server is just a way. This server, this is just a socket which can be used to send data over the internet. This is not um, a full-fledged HTTP request thing, right? This does not use the HTTP protocol. This is just a socket which other device from over the internet can connect to send and receive information, data, and they can agree on a protocol like HTTP or something like that to send data in some specific format. And this one currently does not have a protocol, and I guess I will be making my own protocol later. But for now, I have to create my own. So why am I doing this? I'm doing this because when I do OAuth using Google, I want I have to provide a redirect link to Google so that it can send me the verification code which I get after the user logs in using their Google account. And I want that verification code which I can send back to Google server and get a token, uh, refresh token or access token, so which I can use to access information. That is in this case the live chat for my stream. So, uh, but for that I have to make this public so that anyone over the internet can send requests on this thing. But that has shown to be a problem. How do I do that? I know my IP address. I can find it out by using curl if config.me. This is a website and this gives me my IP address. If I go there, if config.me, I should see my IP. Yep, this is supposed to be my IP address and this is what I got in there, the same thing. And user agent is this KHTML, Gecko, Chrome, Safari, language is this, method was get, encoding was this, MIME type, text HTML, application charset, X forwarded this something, and then curl command line interface, okay, curl if config.me will give me this, Okay, curl if config.me/ip will give me this slash UA is user agent, the one who is sending the request. Curl if config.me/UA. Uh-huh. Uh-huh. Oh, in this case, I am sending the request using curl. Okay, that is good. Curl if config.me/IP will give me my IP address, right? And encoding my, okay, all. Let's see. Curl if config.me/all will give me everything. It gives me the port that I used. Will I use the same port? I guess not. Yep, I used a different port this time. Yeah, that makes sense. Yep, using a different port every time. And is this port mine, like my port, or the port of the website? Remote host unavailable. This is user agent, the one that is sending the request. Language reference connection. Okay, and why does it say Google forwarded this? This is my IP, this much, and then this is something else. Yep, and is something else which remains same in every request. Now after that, there is I can get everything in JSON format. That is also cool. This is my IP address, right? So what I want to know is that, wait, first IPv6. Let me see what it is. IPv6 uses 128-bit addresses. Okay, 128-bit addresses. 128-bit, how many bytes? 128 divided by 8. 80 plus 48, that is 16 bytes. Yeah, yep, that is 16 bytes. 16 bytes can be represented using 32 bits, 32 hexadecimal characters. So are these 32 hexadecimal characters? 4 are here, 3 are here due to some reason, then 4, that is 4 plus 4, 8 plus 3, 12, 11 plus 4, 15, plus 4, 19, plus 4, wait, 1, 2, 3, 4, 5, 6, 7, 8, 8 into 4, wait, 8, and each one of these represents 2 bytes, right? And so 8, yeah, I am representing 16 bytes. But why does this one only have 3 characters? I guess here the MSB is 0, that is why it is only 3 characters there. Okay, so that is IPv6. Now, I have an IPv6 allocated to me. Is it, uh, does it belong to, does it refer to my laptop or to my router? I guess it refers to my laptop. And right, that is my first question. Does it refer to my laptop or to my router? And second, is is it my router that has assigned me this IPv6 address, or uh, does it, yeah, yeah, that is like it. It depends on how your ISP geo, it knows my ISP has allocated IPv6 address. If your ISP gave you a single IPv6 address, this address is likely assigned to your router. Your router might use an AT network address translation or prefix delegation to give your laptop a private IPv6 or local address, right? If your ISP gave you a 64-bit or larger IPv6 prefix, your router receives a public IPv6 prefix and assigns individual IPv6 address to your device, including your laptop from this range. In this case, IPv6 address on your laptop is public and globally routable unless your router applies firewall rules. Run ifconfig or IPA on your laptop and see if your IPv6 address matches the one you believe was allocated to you. Okay, if config. Okay, I see a bunch of things. I don't know if I should show them on the stream. Uh, if config, log into your router's admin panel to see the WAN side IPv6 address assigned by your ISP. Would you like help? Okay. What is if config? If config help. If config illegal. Okay. Help. That is also illegal. Shit. If config L, C and L interface address family destination. What the heck? Uh, man. If config. Yo, that is cool. Configure network interface parameters. Okay. If config utility is used to assign an address to a network is used to assign an address to a network interface and or configure network interface parameters. The following options are available. Address. For the DARPA Internet family, the address is either a host name present in the host database host or a DARPA Internet address expressed in the Internet Standard dot notation. Hmm. Okay. If config. If config. What does this do? What does all of this mean? Okay. Yep, screen is not stuck. Log into your router's admin panel. So, what do I want right now? I want to understand that does my laptop have an individual IP address or is it the router who has a global IP address to which all of the requests go through? Brew install IP. Is that it? Yep, IP. Hmm. Okay, how do I see the IP address and then figure out whether it belongs to the laptop or the router? Laptop or the router, you can follow the following steps. If inet 6, okay. If config grep inet 6 with no space. Yep. Okay, I see a bunch of stuff. And what am I looking for? ipconfig s or ipconfig 6 address show. Look for an IPv6 address that is not FE80 which is a link local address and only used within local network. FE80, which is not FE80. This is not FE80. These three are not FE80, and yep, these three are not FE80, right? Prefix link, okay. And then check your router's IP address. Open your router's admin panel, usually at this or at this. Okay, okay. Look for a section like WAN status or internet status. Let me first print this here. 192.168.1.1, 192.168, comma 1.1. Let's see. Or or what is the other thing? 168. This could be zero. Um, nope, nope. Okay. Yeah. Open your Wi-Fi's router admin panel. Step 3, compare the addresses. If the IPv6 address you found on your laptop machine's router, the router WAN IPv6, then your ISP has given only single IPv6 address to your router. Okay, right. So this command will return some IP address, which is which yeah, some IP address, some global IP address. And now, if this command returns some global IP address, and this global IP address is the IP address used by the other side, that is the server to which I am sending a request, and the server is returning some stuff here. And now if this matches with the router's IP address, then my ISP has given my router only a single IPv6 address, which is cheap, and that IP address just belongs to my router. If your laptop has a different public IP address, then your router has assigned it from delegated IPv6 prefix, meaning your ISP gave your router a range of addresses. Okay, my ISP gave my router a range of addresses. This doesn't seem to work. Point one. What is that? That is that. HTTPS, and that is address bar. That is not working. 192.168.1.1. That is not working. 168.1.1. Wait, compare the addresses. Yep. Alternative, use a online checker. What is my IP address? Compare the IPv6 shown there from the one. If they match, laptop has a public IP address. This, yep, this one matches with the one I received. Yep, this. So this means that my laptop has a public IP address, right? Okay. Now I have a bunch of questions. Let's see. Right. First of all, what is this if config command, and what does it it return, and does it sends request to some remote server? Let's see. If config command, short for interface configuration. Interface configuration is a network management command tool used in Unix-like operating system, including Mac OS and Linux. What does if config do? It displays network interfaces and their configurations, such as IP addresses, MAC addresses, and status up, down. It configures network interface, example, assigning IPs. Okay, it configures network interfaces, example, assigning IPs, enabling, disabling interfaces, though it is mostly replaced by IP in modern Linux systems. Does if config send a request to a remote server? No. If config does not send any network requests, it only retrieves and displays network settings locally from your system's network stack. Okay. Example output of if config on Mac OS or Linux running if config might return output like this. Yep, that is something that I got. EN0, name of the network interface like Wi-Fi or Ethernet. Okay, if config LO0. Okay, and then INET, right? Under this, I have INET, something IP address assigned to the interface. To the, what does it mean? What does the interface mean? I have this 127 is this what I have to type in? No, no, that is certainly not it. If config link local IPv6 address used inside the local network, okay, public or private IPv6, INET6, right, and ether MAC address of the interface. Status active indicates the interface is connected. Status active. This is inactive. Okay. I only want to see the active parts, and well, if I do that, then I will only see these lines which say active. And just let's see if config grep active. Right, I have an active thing in the second last. Yep, this one is active, which is Ethernet and a local IP media skill, and I am saying it like I understand what the fuck I'm reading. And here I have active. Okay, yeah, this seems like the thing. Here I have a local area network, a local area address, and then some public IP v6 addresses. And this is, I guess, my local thing, and this is broadcast. Is this the one for the router? Nope. Nope, it has been blocked. That is okay. Um, they are not working. These IPs are not working. No. Right, and since you are on a Mac, fconfig is still commonly used, but if you are on Linux, you might prefer IP. Well, I'm not on Linux. Okay. Interface. What do you mean by interface? A network interface is a virtual or physical component that allows your device to communicate over a network. It can be a hardware device like Wi-Fi card or Ethernet port, or a software-defined interface like a virtual network adapter. Mhm. Types of interface. Okay, the interface through which the method through which I am connecting to the internet, and it could be Ethernet, wired Ethernet, WLAN. Okay, Ethernet is ETH represented by EN0 or ETH0, right? And Wi-Fi by, well, is Wi-Fi physical? Wi-Fi by WLAN or EN1, and I do see some EN1. Uh, okay, I have internet, but Ethernet. I do not have Ethernet. I have a fiber connection, but why do I see zero here? EN0 means Ethernet here, but I do not have an Ethernet. Yeah, I'll see what that means. Then virtual interfaces, LO loop back, a special interface that refers to the device itself. This in IPv4 and this in IPv6. Okay, TUN tap 0, virtual network used for VPNs, and VR Docker 0, interfaces used by Docker and virtual machines. Why are interfaces important? Each network interface is assigned an IP address and handles communication with different networks. For example, your Wi-Fi interface EN0 or WLAN gets an IP when connected to a router. Your Ethernet interface. Your Ethernet interface ETH0 gets a separate IP if you plug in a cable. My Ethernet interface will get a separate IP. Wait, so do devices get IPs or connections? These interfaces. It looks like devices are not the ones that get IPs. It is the interfaces that get IPs. Your loopback interface LO allows the system to communicate with itself. For network to communicate with itself, like if I have the client and the server both running on my single device, then I can communicate with myself. Yeah? Checking your interfaces on Mac. If config or IP link, show do not have the IP link command. This okay. So interfaces are are methods of connecting to the internet, and this is below even the TCP layer in the IP layer of networking, and it is not the devices that get IP addresses, it is the interfaces. Is that correct? Let's see. Yes, exactly. You got it. Key takeaways. Interfaces are below TCP layer. Uh, interfaces operate at the network layer or the OS of the OSI model where IP addressing happens. TCP is part of the transport layer, okay, which runs on top of IP. Interface, not devices. Get IP addresses. Your device, laptop, phone, router doesn't get an IP address. Instead, it is network interfaces do. It's network interfaces do. Each interface, Wi-Fi, Ethernet, VPN, etc., gets its own IP address. So it is not the device which inherently have an IP address. It is the connections which get an IP address. Okay. A single device can have multiple IPs if it has multiple interfaces. Example, Wi-Fi, Ethernet connecting. Right, right. EN0 means Wi-Fi. I am using Wi-Fi. That is cool. ETH means physical, and this means this IP address. Why do I see this? Wait, and what are the ones that I am getting? LO, which is a way interface to communicate with myself, right? That is cool. And just some unknown a lot of interfaces. And this one, Wi-Fi, this is, I guess, the main one, which I am using to stream and do all the things. And here I see a local network which says prefix length 64 secured scope ID B. B is 11. Hmm. Okay. 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 I see. I see. Right. So, uh, so for a device to connect to the internet, it requires interfaces which are which and it requires interfaces which are interfaces. What are interfaces? Which are ways to send, and not ways, which are mediums, mediums, which are mediums. Is medium the correct word? Mediums are interfaces, mediums. Because interface, but the word itself, interface, means just the interface. Hmm, are interfaces. They are like sockets. Nah, 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 nah. They are much below socket layer. They're below the socket layer. They are the interfaces implement the IP layer, right? And it is called the IP layer, IP network layer. There, which are which are which are methods that implement the network layer, that is address, that is the addressing part of the network system. Yes, interfaces are used to give addresses to devices, and it is the interface which has the address, not the device. Right. So to assign a device an address means that an interface has an address which is used by the device to communicate over the internet. Right. This only involves in giving an IP address to a device which actually belongs to the interface, and the device uses that IP to communicate over the internet internet using the transport layer transport layer implementations, which includes TCP. Right, right, right. Interfaces are that for a device to connect to the internet, it requires interfaces, which are methods that implement the network layer, that is the addressing part of the network system. This only involves giving an IP to a device which actually belongs to the interface, and the device uses that IP to communicate, like horrible spelling, uh, communicate over the internet using the transport layer implementations, which include TCP. Right. Like shit, words are coming out easily, but they are not sinking in. Okay. So interfaces are ways through which I can connect, uh, through which I open a portal, and through which I get an address which I can use to communicate over the internet. Right. Now, right, I know interfaces. Okay. Mm-hmm. 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 That is all. That is all that interface is. All that an interface is. Yes, you have nailed the core idea. Shit, I thought I got it wrong. Okay. Breaking it down step by step, a device needs an interface to connect to the internet. An interface is a hardware or virtual component that enables network communication. enables network communication. Example, Wi-Fi adapter, WLAN or Ethernet or VPN interface. VPN interface, okay. Interfaces implement the network layer. Layer 3. The network layer is responsible for addressing and routing data. For routing, okay, for addressing and routing data. This means each interface gets assigned an IP address, IPv6 or v4. IP addresses belong to interfaces, not devices. A device can have multiple interfaces, each getting its own IP address. The IP address helps identify which interface to send and receive packets through. Okay, and in here I have a local IP and three different global IPs for three different interfaces, which to which I have been connected using the Wi-Fi. Okay, and then IP addressing belong to the interface. Yep. The transport layer, layer 4, uses the IP for communication. Yep. The layer 4, TCP layer, TCP or UDP for reliable TCP for reliable connection and website video calls stuff. UDP for fast connection, connectionless communication. Example, gaming and VoIP stuff in gaming. Yeah, okay. These protocols use the IP address from the interface to reach other devices. Final definition of an interface. An interface is a method of connecting to a network. A method of connecting to a network by means of providing an address, implementing the network layer IP addressing and routing, and serving as the foundation for higher level communication like TCP, UDP. All right, that makes sense. Right. Uh-huh. It is a way to connect. It is a way to connect to the network, right? And if I want to communicate over communicate to a device which is under the local network and not the internet, then I can use that device's local IP and in IPv6 it begins by 80 something. It begins by FE80. FE80. Yes, exactly. In communicating with a device on the local network. If you want to communicate with a device inside your local network, example, another computer or a printer or a smart TV, you use its local IP address instead of a public one. Local IP in V6 and V4 versus V6, right? How IPv6 link location addresses work. Every IPv6 enabled device automatically gets a link local address starting with this. Every IPv6 enabled device gets a link local address starting with FE80. These addresses only work within the same local network LAN. Right, and cannot be routed over the internet. To communicate with another device or using this local address, you must specify the interface because the same address range can exist on multiple networks. Okay, to communicate with another device using this local address, you must specify the interface. Why do I want to specify the interface? The interface. Why would I want to specify the interface? The interface because the same address range can exist on multiple networks. Example, ping this. Here, en tells the system that which interface to use, Wi-Fi or Ethernet. Okay, I have to tell. So shouldn't. Okay, right. I have to tell my program which interface I am using, because interfaces themselves have different local area network. I could be connected on a different local area network through Ethernet and a different local area network through Wi-Fi. Is that what this is saying? For internet communication, if you need to communicate outside the local network, you use global IPv6, which typically start with 2000. Let's see. Nope, this does not start with two. Well, there is 2000, but 2405. Your router assigns these from an IPv6 prefix given by your ISP. Okay, what do they mean by prefix? Second question, and first one, am I connected to different local area networks from every interface on my device? How to find local area network? If config grep init 6, look for this and look for this for global addresses. Okay, am I connected to different local networks for every interface on my device? I guess yes, yes, exactly. Each interface can be a part of a different local network, how it works. Okay, so if that is the case, well, yeah, then I would have to have a mediator, a router, a hub, which specifies local network addresses for the devices connected to that. Like if I am connected to a Wi-Fi, then I have a Wi-Fi router which assigns local addresses to every device, that is, to every interface that is being used to connect to that router. And if I am using Ethernet, then that Ethernet at the other end goes to a hub which does the same thing. Since each interface has its own IP address, it can belong to a different network. Your device can be connected to a multiple network at the same time. For example, multiple network examples of multiple network local networks on a one device. Okay, WLAN or Wi-Fi. This local IP, how do they know that this is going to be my exact local IP, or this is just kind of like a rough thing? Like it generally begins by this. Right now, I am connected with the Wi-Fi, so um, that still does not work. Key points: each interface has its own network, right? Wi-Fi access your home router's local network. Okay, last one can change. Here, last one can change. Local area networks are unique per interface. Since this address only works within the same local area network, you must specify the interface when using them. You must specify the interface when using them. Okay. When using them, I must specify the interface. Checking network for each interface. If config grep init. Okay. What is init? Uh, it was above when I wanted to know about this command. Init, init, init. And this IPv6. What does init mean? What does init mean? Init stands for Internet Protocol. For Internet Protocol, and refers to an IP address assigned to a network interface. Okay, init versus init 6. When you run ipconfig on if address show, you will see two types of addresses, net and init6. And normal init is v4 and init6 is v6, right? Which is something like this, and this one is something like this. Init IPv4 address are like these, and 6 are like these, starting from 10 to 3. Example output of IP address show. One low, right? This is to communicate with myself in it, and init 6 host to communicate with the host, that is my laptop, and over the Wi-Fi, this is my local area uh, network. Okay, I am only having N6, that is cool. This is my local IP. Let's see, that should not work. Yeah. Wait, but I guess low. So when it says low, this could work actually. Maybe, I don't know. Now it refused to connect. Okay, and how to find your IPs? This this in it. Okay, okay. I have IPv4 addresses and IPv6 addresses, right? And I had another question, which was, right, for every interface I have different addresses. Okay, but here, why do I have three addresses for a single interface? Here, here, why do I have three IPv6 addresses for a single interface? Let's see. Great question. You have multiple IPv6 addresses on your Wi-Fi interface because of how IPv6 handles addressing. Let's break it down. Why do you have multiple IPv6 addresses? Each IPv6 enabled interface can have multiple addresses serving different purposes. Okay, local area. This one is for local. This is used for local communication within the same network segment. It is automatically assigned and always exists. Global unicast address. This one, you have three IPv6 addresses in this subnet, which is likely assigned by our ISP. These are routable on the internet. Understanding the types of global addresses you have. This, and this. Stable global address. Used for identifiable internet access assigned via Slack. Previously used for privacy, but now is replaced. And current temporary address used for privacy. Changes periodically to avoid attacking. Okay, why temporary IPv6 address? Uh, IPv6 auto configuration is like Slack assigns a stable global address to your device. Okay, to improve privacy, IPv6 also generates a temporary address that changes over time. The deprecated address is an old temporary address that your system will stop using soon. Okay, how to see expiry times of these addresses? Yep, if config en0, if config en0, let's see, how do I see the expiry time for, okay, ooh, this one is stable. This is the one that was used earlier, and this is the current temporary address. Okay. Summary, your link, this address is for local communication, or this address is for the internet access, and you have temporary addresses. Okay, now, so my laptop has an interface through the not Wi-Fi, which gives it an gives it a global IPv6, which gives it a global IPv6 address, right? And well, I can see my chat on my phone if I see start watching the video on my phone, and let's see. Um, just a minute. Switch account. Let me switch to my account and watch my stream. And yep, watch my stream and see live chat is if there is any. That is. Nope, there has not been any live chat, and I just sent a heart. Ah, two hearts. That is crazy. And let me reduce the volume and go live. Yep, do stuff. See the chat. There is one user, that is me. And wait, what? The stream is the stream stuck, or is it just me looking down? No, the stream is not stuck, and that is cool. So, yep, I can see the live chat there. And well, after then I have when I have created this program, I will be using it to see my chat, which will be cool. Now, yes, it gets a global IPv6 address. So my laptop has an interface through the Wi-Fi, which gives it a global IPv6 address. And okay, address. And so now, what does the port mean? So addresses are mapped to interfaces. Now, what do ports signify? Do they exist on the computer level, or do they come with the interface? That is, does the assign laptop has a fixed set of ports, which are just numbers that it assigns to different programs, to different interfaces, or that it assigns to different interfaces, or do the interfaces themselves have a set of port numbers, and do the interfaces themselves have a port number, and they can be used by the laptop to communicate. Right. You are absolutely on the right track. Let's break it down, the concept of port and how they relate to both your device and ports. Where do they exist? Ports are associated with a processor application, not directly with an interface. They are software-based identifiers which used to facilitate communication between processes running on your device or other devices on the network, used to facilitate communication. Okay, ports and interface. Ports don't directly belong to an interface like IP addresses do. Ports do not directly belong to an interface like IP addresses do. Instead, ports are used in transport layer, TCP UDP, okay, to identify a different services running on your device or a remote server. How ports work. Device level, laptop, computer. Every interface on a device can use the same range of ports. The device has a global set of ports from 0 to 65, which is like how many bytes? I don't know. And these ports are not tied to a specific interface. Instead, they are used by various applications to send and receive data. Port range. Well-known ports. These are used for commonly known services like HTTP, which is port 80, and HTTPS, which is port 443. Mm, resign registered ports, that is from this to this, used by applications that are not part of the well-known services. Dynamic and private ports. The ports at the end are used by client applications to establish connections, then interface and port interactions. If you are running a web server on your laptop, for example, the server might be bound to a port 80 on the global IP and assigned to your Wi-Fi interface. That makes sense. The port is available for communication over the entire device, regardless of the interface you are using. The port is available for communication over the entire device, regardless of the interface you are using. So, if just somehow I get to a device using any interface and then specify a port, then I will be able to communicate to that port if even if it is running on using a different interface. Huh. If you are switching interfaces, example connecting to internet Ethernet, the application can still use port 80. However, different IP addresses might be used depending on the interface. Port binding: when an application listens on a specific port, example a web server on port 80, it is bound to the port. Binding happens on the device, not at the interface level. Bounding happens on the device, not at the interface level. The IP address used by the interface determines how packets are routed to your devices. To your device, the port remains consistent for the process. Example, the web server. Example scenarios, let's say Wi-Fi this, IP V4 and V6 for my Wi-Fi. This is local area network, local address, right? And then Ethernet. This is local network address, and this is also local address. You run a web server on port 80, and this web server listens on all private IP addresses and interfaces on the laptop. On Wi-Fi, available at this, and on Ethernet, it is available at this. That makes sense. Yep, I just have to get to a device using any of the IP that a device has through any of the interfaces, and if then I specify the port, then I can get to the application which is running and listening on that port. The port number 80 is the same, but it is associated with different IP addresses for each interface. The port is global to the device, but port is global to the device. That is, can be if I have reached the device, then I can reach the port. But which IP address gets used depends on the interface. To summarize, ports are a device level resource available across all interfaces on the device, used to allow multiple device level. Okay, it is the device. So it is the kernel that gives access. It is the kernel that manages ports and the programs which are listening on port. Yes, exactly. The kernel is responsible for managing ports and the programs that are listening on them. How the kernel manages ports and listening programs. Port management. The kernel maintains the port namespace and manages the allocation. When a program, example web server, database, etc., wants to listen on a port, it requests a port from the kernel. using a syscall. The kernel checks whether the requested port is available that is not already in use by another program and then assigns the port to the program. Creation. Socket creation. Socket creation. Socket is a transport layer interface which is used which is used to specify the address and the port and the communication protocol, that is data transfer protocol, that is TCP or UDP, used on that port to transfer or get data. To create a socket, the programs communicate over ports using sockets. A socket is a software endpoint that allows programs to send or receive data over the network. Endpoints. To create a socket, the program makes a system call to kernel using the socket function in C. Once the socket is created, the program can bind it to a port using another system call, example bind. In Unix, Linux systems, listening for ports. Programs that want to listen for incoming network connections. Okay, I first create a socket and then I'll bind it to a port. Okay, programs that want to listen for incoming network connections, such as a web server, use the listen system call to instruct the kernel to accept incoming connections on a specified port. For example, a web server might bind a socket to port 80 and start listening for incoming HTTP requests. Connection handling. When a client connects to a server, example through a browser, making an HTTP request, the kernel handles the network packet routing and establishes the connection between the client and server. The program can then receive data, example, the HTTP request, and send a response using the socket that was bound to listening to the listening port. Okay, port binding and network stack. The kernel ensures that the program is only allowed to bind to ports that are free, not already in use. This is important to avoid conflicts and ensure that multiple programs can use ports efficiently. The network stack part of the kernel takes care of the low-level details like routing packets between network interface and managing the flow of data. Key points: kernel manages the namespace. Okay, ports also make sense. Now, if I run a program on my laptop that runs on a specific port number and send a send a request to that port using some send a request to that port send a request to that port using my global IP address, and then port number will be able to communicate. Yes, and after this, a couple of more questions. Yes, you can communicate with a program running on a specific port using your global IP address and the port number, but there are a few important details to consider for this communication to be successful. Key conditions for communication. Program listening on the port. The program must be actively listening on the port you want to communicate with. Yeah, okay. The program binds to that port is ready to accept incoming connections. Okay. Port 80 is used for HTTP, and currently my laptop is not serving as a server. So if I do 80 here, I should not get any errors. Slash server already in use. So what the fuck is using it? How to see program using a port. Yep, in net stat. ANO and enter. Uh, net stat ANO. That is illegal. That seems to be illegal. That does not return anything. Net stat. Let's see. Net stat. Okay, I am seeing some stuff. Established. Are these requests which are going out and in? I guess not because I am streaming and there must be a lot of requests, connections going in and out. Active internet connection. Okay, that is a lot of stuff. Flags and stuff. Wait, that is quite a bit of stuff actually. Local address, foreign address. Why do these have local and foreign address at the same time? Hmm. Hmm. Mm-hmm. 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 The ending address is changing. The local address at the end is changing, but this is this didn't change. Right? Was it? Oh, I don't know what the heck is this. Right. Global IP address. You need to use your global IP address, public v6 or v4 address assigned to your device in the request. This address is routable over the internet, so the other devices can reach your laptop from anywhere. Correct port number. Give the correct port number. Okay, the port number in your request must. Oh, that is why I will not be able to communicate using Postman because I'm not providing the correct port number because Postman uses HTTP request. Right, right, right. So if I specify a port number in Postman, I should. Okay, I have to get my charger. If I run my server, and server.c after changing the port number, that is, um, let's change this to 1205. Is that, no, that is cool. That is just 12,000, which is cool, not bad. 1205, and this is my IP address and all this stuff. And post socket hang up view in console. Look, I want to see the console. And what is the error? Find and replace, send again. Okay. Uh, oh, yep. Socket hang up, request agent runtime accept. But I do get something there. Right? I do get something there. So if I, on receiving this, if I return something, then I will see that something on Postman. Okay, okay. First, let me get my chart. Yep, I'm back. My laptop is charging. And shit, I guess someone is watching my stream, which is fine. Yeah, so the thing is that I am sending request from Postman, and Postman is giving me error, right? Okay. because nothing is being sent back from the server that I created here, right? But on the server side, I am getting request, right? Okay. So what I want to get is give me, like, I am using socket in C to communicate, and give me a string that contains the required things, that contains the things which are which follow the HTTP protocol, which follow the HTTP protocol uh, as a return to as a return as a return as a return to a post request. Let's see. Yeah, it is simple. Okay, this is what I need to send back. And okay, HTTP response. Let's just send it plainly. And response. Okay, I'm not sending anything back. I'm just printing it. Right. So first, how to send back a response using socket. Here in this line, I am accepting a response and seeing if I do get a new socket in the case of the connection, and then I am printing that I have accepted something. And let me here say, right, this is going to be my response, a request success. Yep, I am creating it. I am binding in this part, listening for incoming requests. Client FD accept. Yep, I will accept something that I get. Right, accept. Yep, I'm calling it new socket. They are calling it client FD. That is also okay. Now I'm seeing n equals read client buffer. Client buffer size of buffer -1. And what am I doing? I am doing this to read it again, which is I guess also good. Okay, so do I have to read it using the format? Buffer size is backlog is 10, socket len buffer char buffer. Okay, I think that this read function is equivalent to this recv function, but in this I do not get this n, so I can just skip that and at the end provide this printf and print the buffer. This is the function used to send yes new socket and HTTP response. Then okay, then I provide the string constant char pointer, okay, and then the length of the response and comma 0. 0 must mean the protocol that I'm using. Right. So after printing it, I will say send. It takes in new socket, comma, then HTTP response, right, and then length strlen of HTTP HTTP response, right? And then zero. This should send something. Let's see. Client server dot slash server, right? And if I just run the client side code, I do get something. And if I do this, uh-huh, uh-huh, what do I get? Right, this is the new error. And is this different than the last one? I'm still getting an error here. No cache request handler. Parse error expected HTTP. Okay, expected HTTP. Is this not HTTP? Prepare to send the HTTP response. And server, let me change this. I guess it is already the same. Yeah. What do I want? I want to say, okay, I am getting error that. Oh, wait. I can also make changes on the client side to see the response after sending. Instead of just closing the circuit, I want to see the response that is sent back. Yes, I can send using that. Send socket message is returned 0, and I can uh, send read. Yep, read takes in an integer, which is, what is it? An integer, which is, what was the integer that was provided in read client. Okay, the that for the that, but I do not have that. Wait, I do I? Is socket init 0 is stream server address. I guess it is server address or sock. I have to create a socket for the client, right? So this connect sock with this. Do I have to do accept? Nope. Oh, yeah. Requie. Let's say requie, and I will provide here server adder. Is that correct? Yep. That seems to be. And the second thing is going to be a buffer, and the third is going to be uh, buffer size, and then 0, and then nothing, right? And 26, I will define buffer size to be 1024, and here I will declare a buffer char pointer char character buffer buffer size. Right, that should be cool. Nope, that is not cool. Close client and close server. Okay, and when I am in this server code, when I am doing a read, yep, here record VC, I am doing new socket, which is what I get after response, after I accept, okay, which is a number. Okay, so do I have to connect in the same way that I did here? Nope, I cannot do that. I have to provide address, server address, and stuff to do a connection, right? So how does the server send back a response to the client? How does the server send back the response to the client? Okay, after this point, we are connected. We are both connected, and yep, we are both connected. And new socket, right? I send. Yeah, I guess the output of connect is what I have to use there as the integer, right? And new socket, where did I define new socket? No, it is an integer. Okay. It is an integer. Okay, and I will define it here above new socket. Yep, and here I will do this new socket equals this, and keeping in mind the precedence of this stuff, I'll do this, right? And in here I have to provide a new socket. Now after this, printf response %s and new line, comma, comma, a buffer, given the buffer, and backslash new line. After this, right? And then after this, client, client, client server, and stop this dot slash server. Let's see dot slash client, and response is nothing. Okay, do I have to wait? Do I have to wait for some time before I get the actual response? This so sleep for 1 second. Let's see, and um not client client dot slash client message sent, and the response is nothing. Okay, server dot c, and in here I am sending, right? I am sending something, so it should be received on the other end, and I am sending using this send command in here, and in the client code I am sending using the send command, right? And send sock sock and receive socket. Okay. Hmm. Not new socket, but socket FD. Is that it? Right. And here I connect with sock, and I am sending with sock, but I am receiving on the socket that was connected. Clang server, clang client dot slash server dot slash client message sent, and a response is nothing. Shit. Okay, so what am I trying to do here? How to send a message from client to a server, and then respond to the client from the server. To send a message from a client to a server, and have the server respond to the client, you need to implement both a client-side and server-side program using sockets in C. The client sends a request message to the server, and the server processes it and sends a response back to the client. Here is an example server code. See, right? In this I have a port, I have backlog and buffer size. Then I initialize a client FD and a server FD, right? And a struct socket address initial for server address and the client address. Let me figure it out on myself. In server.c, here I can say client FD, like is FD, client FD, server FD. Okay, let me just put them together and do my stuff. Yeah, this becomes server FD and this becomes client FD. And yeah, replace question mark s this s percent s, replace socket fd with server fd on every line, right? That is cool, and new socket is gone, right? I would like to change new socket's name also. This percent s and new socket, change new socket with client socket, client socket global, right? The CLIENT client, so with client FT, okay. Percent S client socket with client FT globally, right? And I have no now, right? And then server address and client address that I do due to some reason already, and then address length, size of client address or server address, doesn't matter in the beginning. And then I create a buffer, right, of buffer size, initialize it all to 0. Then I am creating a socket. Yep. In this step, uh, IPv6 socket stream is TCP, and if I do not get a socket, then I return native one. Okay, server FD is an integer which contains an ID for a socket. And then server address, in server address, I'm setting the properties. The family is v6, and it can take in requests from anywhere, and it has a port which is 12345. That is crazy. And then I bind that socket ID with these options, right? After binding, I listen for incoming requests on the server, like this. Listen, and 5 backlog 5. Let me change this to backlog, and above say define backlog as 10. If after bind, I listen, and then I print that I am listening, right? And yep, that would be cool. Here I can do this %d and then given the code. Yep, and then while true, I'll do client fd equals except server fd except on this id. Yep, except on this id, and I guess update the options for this address, and this is the length of the address, Okay, and if client FD is less than 0, then print error, otherwise say connection accepted, right? Which I do. And then after saying connection accepted, I, I connection accepted, I do not print the message, okay? And I make a response which I want to send. Message received successfully, okay? This is a constant char pointer connection from client. I do read the Yep, I do read the buffer using the read function and okay. And read will return the number of bytes that it wrote that I read. Okay, so I can remove this recv and do int n equals read. First one is an integer, which I guess it would be client fd. Yep. Client fd. What is client fd? Client fd is the ID of the client socket, presumably, and then the buffer, and then buffer size of buffer -1. All right, and then if n if n less than -1, then if n equals -1, that is I got some error. P error, couldn't read what the client sent, and I will close client fd and the server fd. Okay, close client fd and close server fd, right? And oh, exit exit with exit failure, right? If exit failure, how do you exit an exit failure? After that, I will put a null character at the end of the buffer now, and printf, not response but request \n %s comma buffer, and after that a new line, right? After that, I prepare my response, which is HTTP response, and I send. Yeah, I have to use client fd, okay, and then length and then 0. If it is less than 0, then I do error, right? And if this is less than 0, then I do p error sending failed and close the client and the server. Client fd and close server fd and exit with exit failure. And otherwise, I print response sent successfully, new line, right? That is going to be it for the server side, and for the client side I have this code, right? For the client side I have the server address, which is cool. Then I initialize a socket client called client fd, okay, client fd I will call it, and then socket address, server address. Right, here is my message which I am going to send, and here I have a buffer which will receive the response. Then I create socket client fd, right, and I will see that if it is less than 0, then I will print error. Otherwise, memset and I do stuff. Server address after initializing the client socket. Memset address of server 0 and size of server. I will just remove it because I don't see it there on the left. I don't even know what that meant to begin with. And why the fuck is this here? I can define the port here. Define port 105. Right, that is cool. And here I'll use port. Right, and now if new socket equals connection. Now that is not what I want to do. Right after creating the client socket, set server address, right, which is this part, and then I call this function, yep, with the appropriate things, yep, with the appropriate things, and then connecting to the server, which is the connect function. Okay, I guess I will not need this. Right, and right, sock does not exist because it is called client ft. Now if it is less than 0, I will print the error, otherwise this, and then connect it to the server. Right, I can say printf connected to the server /n, and then comes the send command, client ft, sending to client fd. What am I sending? I am sending the message, the string, and 0 at the end. Then I am printing that message has been sent, and then I am listening for a response. Okay, that seems simple enough. Int n equals read. Let's see, what does the read command require? It wants an integer, which I suppose is going to be client. Okay, client, and then buffer, and then buffer size of buffer minus 1, size of buffer minus 1. Right, and then if n less than 0, then p error could not uh, read response. Close the client fd and exit failure. Right, and if n is less than 0, do all of this. Then after that, if that does not happen, then put the last character in the buffer equal to null. And okay, was that the thing that I was messing up, that I was not putting null at the end? Shit. Received from server \n percentage \n comma buffer. Right, and then just close client fd. With that should, I guess, work to send and receive responses like that. Let's put it there. Yeah, see, clang server and server.c and clang server clang client dot slash server, right, and here dot slash client. I did get the response. That is cool. I did get the response. So the server is online, and if I send from Postman, will I get something good? Let's see. I should get something good, which I do not. That is also fine. Uh, okay. This is the error I am getting. Okay, port number, network configuration, firewall settings. Okay, when sending HTTP request to my server and then responding with a HTTP response, I am getting error. This that you are encountering is okay. Uh, uh-huh. Mm-hmm. Mm-hmm. This is the HTTP response, HTTP request that I get from Postman. Mm-hmm. Right, I can just do a get request and see what I get on the other side on my server. I got this HTTP one to Portman, Postman, right, and Postman token and stuff. Host is this, right, and accept ending keep alive. That is cool. Connection. Why do I see connection here? Right, it was printed because I selected it. Now, what do I want? I want to send a good HTTP request. This format doesn't seem to work, and this is the thing that looks like will work. Make file when your server sends a request. Server responds to the request. It should also have a valid HTTP response format. For example, this print this. Right. This seems like this could be a valid request from the server or slash server. Let's see. I am listening on the port and then I send a request and then I get error, which is not cool, not cool, not cool, not cool, not cool, not cool. And this is what I get from the Postman side. Right, and show you, okay, mm-hmm, mm-hmm. Example Postman request. Here is an example of a well-formed HTTP Postman post request. Okay, here is how my response should look like to it. Uh-huh. Server.c. So I have to change the response. It should be something like this. Okay, and this. Let's see. Control C, and server is running. If I send a request, should I get something which is not an error? Nope, I do get some error. Why socket hang up? I am getting socket hang up request. This was the header that I sent, and now I am getting socket hang up request. Let's see, socket hang up. Socket and hang up typically occurs when the client, example Postman or browser, successfully connects to the server, but the server unexpectedly closes the connection before it sends a response. This can happen for several reasons, such as server not handling the request properly. The server might not be correctly handling the incoming request, or it might be encountering an error and closing the connection. Uh, so the server is online because of the while loop, I guess. And let me remove the while loop then. Client server dot slash server. And what am I trying to do here? Trying to establish HTTP response. Yep, this time it again hung up. He hung up on me. Shit, server.c, and let's do a read, and except this whole thing has to come in the while loop, and till which point? 27, this one. Client server dot slash server dot slash client. I am getting a response in the client, and this is wrong. This is, yep, this is wrong. This is wrong. Server.c, this is wrong. I have to have backslash new line here. New, wait, is that it? New line? Client server dot slash server dot slash client. Already new, right? And client. Yep, this might be it. This might be it, or might not be it. Yep, it might not be it. Right, it hung up. It hung up. The server hung up. Why did it hung up? Server.c, it hung up in case a specific one port in case is able to respond to post request. I am now doing this get request. The server might take too long to respond to process the request, causing a timeout and the connection being closed. Nope. Server crashes or early termination. Nope. I am sending the request, right? Because response sent successfully. This line is printed uh, after the response has been sent. You have to do this. I was closing this connection maybe too early. Dot slash server. Let's see. Huh? Okay, I'm getting something. After sending the response, I have to wait. Okay, I'm not closing the connection because I have put the close connection request after the response sending part. So if I do in this line, I am sending the request, and then I am printing that I have successfully sent the request. And after that, I am closing. So I have to close. Let's say after sending the response, I will sleep for 2 seconds maybe, and then close the connection. Client server, right, and control C dot slash server dot slash server. Who the heck is using it? Nope, it is me. Client server dot slash server. Net stat p what is it, 5? Is that correct? Nope. Net stat unknown argument. Yeah, here I should, yep, I got an error timeout. Socket hang up error because I closed it. Yep, because I closed it. Ah, now it should work. Yep, now it is working. And if I send it now, after 2 seconds, it will end and I get an error. Right? Uh-huh. Mm-hmm, mm-hmm, mm-hmm. Net stat an net stat an in grep 105 t6 store increase timeout is there. JavaScript set header. Fuck. Let me show ChatGPT my exact response that I am sending. This is the response that I am giving back, and let's see. Add a response body here. Okay, but that was not the server. That was not the problem. The problem was something else. Server, and let's see if I send that request now. Okay, I'm not even waiting for 2 seconds now. I'm getting the error immediately. Okay, maybe this might be another error. This is parse error, expected HTTP. So this is not valid HTTP. What was the thing that I was sending earlier? Earlier I was sending this, and now I am sending this. HTTP, yeah, content type, application, JSON, and then this. And yeah, okay, that is exactly the same. This is the new one. This is the new one. This has, okay, that is the same. First line same, second line is also same. Third line is a bit different, yeah. And this, which is also cool, right? Mhm, mhm. Yep, this should be what I see in there. The server is online. And dot slash client, I should get this thing in client. Yep, I do get this thing in the client. Explanation of changes. Yeah, it is saying that I should give this an empty, yeah, I can give an empty body if that makes it work. I can give in an empty body. Yeah, paste. Okay, dot slash server, run the server. Let's see. This should give me error. Oh, I got something. I got back a response. Okay, that is cool. That is really cool. Shit, I got a response. Oh, error. Error on the third request and read incorrect something. Let's see. Yep, maybe I sent it too fast. And server, where is the sleep? I will remove the sleep command. Client server, See server. Oh, it is already in use. Now it should. Who am I responding to? Boom. Okay. Here if I do this right, that is cool. Okay. Now I am listening on port 12345, and if I send the response, and I can send the responses faster, fast. Just keep clicking. That is cool. Yep. Visualize. Okay. That is cool. That is cool. That is cool. Server.c. Let me say body. Body is a char pointer body which equals this which equals this okay, these brackets, and inside them I have this and another one of these, and inside this has a key. um right. Char, what did you expect? Expected expression. Char body pointer. Okay. Expected expression. Char array. Char body. Expected expression. What does it mean? Expected expression. Constant char pointer equals something, right? Char string equals hi. Uh, okay, it is still there. There was something there. Okay, right, and then I'll have this, and then will come the value, which is just value, and this, right, and here after this can I just say body? Yep, I guess not. Yeah, body, I cannot say that. I have to provide content length in here. So I have to get this thing here. Get this thing here. Right, right, and content length. It is going to be, what is it going to be? Earlier it was 20 when I was sending a body 20, and what is it counting? Everything inside these brackets, I guess. One, two, or I can just do Sterling. Right. Can I do this? The length of the body. Yep. %d, and that is not formatted as string, so that will not work. So let's do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Client server. Stop the server. Run it again. And let's see. Does it work on? Do I get some value? I get some key value pair. That is cool. So in this case, I have implemented my own HTTP server using sockets in C, which is cool, I guess. Okay, I can handle HTTP requests in this way. That is cool. Now, the thing that I want to do is make this public so that anyone can send, so that even a friend of mine can send some request to this on this endpoint. And for that, I can call a friend of mine. It is about 10 o'clock. He should be awake. But I will do that after the stream. I will send him this link and tell him to send a get request on this. Or wait, this is a get request, so I should be able to paste it in the browser itself and get something. It is not secure. That does not matter. Just cookies and site data is not secure. Okay. Yep. Should I really want to check if that if I send this URL to a friend of mine, will he be able to send a request to my server in Postman using Postman? And I really want to do that, and therefore I am ending the stream right now and I am calling up my friend like I did yesterday. And this should be easy. He already has Postman installed, so this should not take any more time. And now and then after this, I will stream in the afternoon, and we will continue. And what do I want to do next? Yes, if I know that my server can take a response globally from any URL, then what do I want? Yeah, if it can, wait, let me ask, talk to ChatGPT for a while. Since I have a IPv6, uh, wait, yeah, I had a few questions, which was that um, firewalls stop incoming requests to my device from unknown IP addresses. And yeah, let's see, is that correct? Yep, firewalls are typically configured to control and filter network traffic based on various criteria, including the source IP address, port numbers, and protocols. Firewall walls can block or allow incoming and outgoing network traffic based on the criteria. Okay. If I go to my setting, can I see the firewall settings? System settings, and open my firewall for a specific port. Let's see, firewall, advanced firewall settings, turn firewall on or off, firewall is active, options. Let's see, port number. These are all the things that are running right now. And wait, I saw a Ruby in there. Yeah, okay. Allow incoming connections. Block all incoming connections. Nope. Enable stealth mode. Don't respond to or acknowledge attempts to access this computer from the network via test applications using this and ping. Plus, I want to give access to my C program. Eh, fuck it. Um, how how can I turn off the firewall for a specific port number? To turn off or disable the firewall for a specific port number, you will need to modify the firewall rules to allow traffic through that port. This can be done using the built-in firewall utilities on your operating system, such as IP tablets on Linux or PFCTL on macOS. PFCTL, no, not on Linux, on macOS. Yep. PFCTL. On macOS, the firewall is typically managed using the PF package filter system to allow traffic. Okay, sudo nano slash etc. Modify the open the file in a text editor. Okay, pf.config and n is like newvim, not like it is exactly newvim. Oh, it has to be a sudo function. Sudo and etc slash pf dot conf. Okay, I will enter my password and invalid version ls slash etc slash pf everything, and I have ef pf conf and pf os sudo and etc slash pf dot conf. Invalid version. What do you mean invalid version? cd c slash pf ls. These are all the things I have in here. And cd pf dot conf. It is not a directory. Okay. Then so can I print it? pf dot conf. Okay. There is some stuff default pf configuration. And pf dot conf. Okay, it is open now. This file contains the main rule set which gets automatically loaded at a startup. PF will not automatically enable. However, instead, each component which utilizes PF is responsible for enabling and disabling PF via care must be taken to ensure that main request. I have a bunch of stuff in here. Then what do I do? Pass in proto TCP from any port. This add a line to allow the on the specific port, for example, to allow on port 1, 2, 3, 4, 5. I have to write this. This is a read-only file. Uh, Cannot open file, writing permission denied. Mm, I'll just exit then. Force exit. Right, apply the changes. I cannot change the PF. Let me first see and ask my friend to send a postman request and see if this works. And then I will take it from there. Yep. And that is the end of the stream today.